Hello, TikTok and YouTube land. Before we get started, I would like to say thank you to everyone who has been subscribing, and thank you to everyone who has taken the time to like these videos. If you're new to the channel and you enjoy the content I'm producing, go ahead and hit the subscribe button. If you're a returning viewer, please leave a comment and tell me how I can improve the experience for you. Otherwise, let's get started with Chapter 10 of Sander Van Voigt's RHCSA EX200. In this chapter, we're learning how to manage Linux processes or applications. So last time we learned how to install them. This time we're learning how to manage them. Very, very easy, boys. Like most of these videos, before we get started with the practical stuff, we need to discuss some theory. So there are generally 3 or 4 different types of Linux processes. Hold on, I have a cat in the way. Now that that cat has been placed somewhere safe, let's continue. So there are 3 types of Linux processes. There are shell jobs, otherwise known as interactive processes. There are daemons, not demons, daemons, which are basically processes that provide services. So a web server would be a web daemon. And then there are kernel threads, which are generally processes you can't really mess with too much because they will break your system. So Linux tends to lock those down and keep you from messing with them. All right, so now that we know some basic terminology, let's talk about one more thing. So basically every process on a Linux server creates what are called threads. And what threads are dedicated channels that the CPU can use to complete those processes. Some processes can have multiple threads, and threads are normally controlled within the process. And that's that. Go ahead and tune in to the next video where we talk about actually managing threads and processes. Last time we left off talking about the different types of Linux processes. This time we're going to talk about the 2 different modes they tend to appear in. Those 2 different modes are either background mode or foreground mode. Most Linux processes are in a background mode, meaning you can't really interact with them. But some processes, when you start them, like either via script or command line, you'll have them in the foreground, and they'll either give you a command line or they'll give you like a status output message. I'm going to show you how to switch those processes to background mode or bring them back to the foreground if you still want to manage them. How do you switch between background mode and foreground mode on Linux apps? It's pretty straightforward. We would do VI, and then a couple of videos ago we had a file called grep.txt, so we'll use that one again. And using that, we now have VI in foreground mode, and it's in foreground mode because it's interactive. What if we wanted to put this in the background and not necessarily save our work, but reference this later? We'll hit escape and Control Z, and you'll see we got a message that this process is now stopped. And with that, we have just moved that process into the background. All right, so we did whatever we needed to do, and now we have to hop back into VI again. So how do we pull this application back into foreground? Well, we'll do foreground, and this is actually the second foreground process I have, so we'll do 2, and you'll see we're back in foreground mode, and we're back in VI exactly where we left off. Very convenient stuff here. So we can use the FG command to move a background process into the foreground. We're going to use the background process or the backbg command to list our current background processes. So as you can see, we have one background process that's another VI session. So if I were to do FG1, you would see this is a completely different VI session than the one we were in before because this one's empty. And then I actually properly quit the session. And now when I list background again, we currently have no background jobs. This is very useful because we could do stuff like top, which lists all our processes, and move this to the background. As you can see, we now have one background process list again. We use the background command again to list our processes, and it shows us top is listed there as number 1, and it is currently stopped. What if we wanted to start a process as a background process? Well, to do that, we would use the and sign. So for instance, if we were to do vi./grep.txt, and instead of opening the VI menu or the VI interactive shell, we now have a process and a number. And then when we list our processes, you can see there's that command we ran, and you can see it's got the and sign right there. So for us to actually pop back into the VI shell, we would do foreground 1, and as you can see, we're now back in VI. And then we can do insert And then we can do test, just to put some lines in there. And then we save and quit. And there we go. And because we actually quit VI, when we run background again, we have no background jobs because VI is no longer in the background. What if we want to list all the current background processes on this host? To do that, we use the jobs command. So we could do jobs. As you can see, it shows two background processes. We have VI grep.text and VI anaconda.config. All right, so let's practice with shell jobs a little bit more. This is lab 10-1, managing shell jobs. The first thing they want us to do is, of course, open up a shell as a root. So we are a root account. Then they want us to type in some commands. The first is sleep 3600, and of course we pass the and sign. And then they want us to do, let's see, f equals / dev0 of equals / dev0. Then they want us to pass the and sign. Then last but not least, they want us to do another sleep for 7200 seconds. So we just started two processes in the background, right? One is a sleep counter for 3600 seconds. We then did dd if dev0 of dev0. So we're basically writing nothing to a file called nothing, right? And then finally we did a sleep 7200, which is running right now, which is in the foreground. What if we want to close this process? Well, we simply hit Control Z and we've closed that process. If we didn't want a list of the processes we had running in the background, we will type jobs. As you can see, we have three processes running now: sleep, dd if dev0, and sleep again. What if we wanted to bring this background counter job back to the foreground? We would do foreground 3. We could then close it out. What if we wanted to bring this first counter job back to the foreground? We would do foreground 1. What if we wanted to just cancel this foreground job? We would do Control C. And then if we list our background job again, you'll see, or rather if we list jobs again, you'll see now we have two jobs running, number 2 and number 3. Notice number 1 disappeared, but those other jobs are still there. Now, what happens if we were to open up a second terminal? I click New Tab, and basically we just open up a brand new terminal session. Let's list jobs. You'll see we get no result because this terminal has no jobs in the background or the foreground right now. Now, let's try that same command we did before. Let's do dd if / dev0 of equals dev null. And then we close this terminal. Then we go back to our first terminal. If we were to do top, and at the top you'll see we actually have that dd command still running right there. Even though we closed that terminal, it just became a background session when we closed that terminal. To my left, you'll see a process menu. This is a process monitor called HTOP. It is one of my favorite monitors to use. If you're eagle-eyed, you'll notice that HTOP has different processes moving up and down. What controls these different processes? Well, that actually opens an entire Pandora's box with your questions. What controls the priority of these processes are C groups. What are C groups? Well, C groups are groups of processes that are put together, and then those groups of processes are then allocated shares of memory and CPU time. There are 3 primary C groups. Those 3 C groups are the system C group, which is for system processes, so that would be systemctl. The user C group, which is for user processes, so that would be anything you start from the shell. And the machine C group, so this would be for like your virtual machines and your containers. By default, all C groups carry the same weight or level of priority on a Linux system. You can change a process's priority by changing its nice level. So if you were to re-nice a process, you would either be making it more important or less important to the Linux system. So what is the difference between nice and re-nice? Well, nice is used to set the priority of a task we haven't started yet, and re-nice is to change the priority of a currently running task. Let's practice using them. To start processes with a particular priority, we use the nice command. So for instance, we could do nice -5 to set the nice level to 15. And then of course we write nothing if dd, and of course we write nothing, and then we send this to the background. The cool thing about that is it also gave us the process ID. Because we have the process ID, we can then find this process in HTOP, which it is right here. And as you can see, the priority is 25, so it has a higher priority than any of these tasks. So what if we wanted to change the priority from 25? Well, we would renice it. So first we close HTOP, then we do renice -N10, and then we send it to the process, which is 524384, right? And now when we open up HTOP again and we search for the where is it here? There it is. You'll see the priority is now 30, meaning it has a lower priority than other hosts. So when it comes to nice or priority level, the lower your priority or nice level, the more important you are. So we learned how to change a process priority, but what if we want to end a process? Well, when we go to end a Linux process, we're actually sending a signal to that process. There's actually 3 different signals that are sent to Linux processes. Let's dive into those real quick. There are a bunch of different signals you can use to end a Linux process. If you were to do man7 signal, let's try that out. You see all the list of the different signals you can send to a process to end it. So there's raise, kill PG, pthread, there's a bunch, right? The good thing about this is you only need to know 3 of them. The first is sigterm, which is basically used to politely ask a process to stop. The second command is sigkill, which is used to force a process to stop. That's the not so polite way to ask the process to stop running. And the last one you absolutely need to know is sigup, which is basically used to reload the process. If you ever hit the reload button in Chrome or another web browser, this is the equivalent of that. It reloads the configuration files of whatever process you're running that command against. And we have one more signal. You don't need to know this, but I felt like it was nice to give a shout out to someone who helped educate me. I am mentioning Adiana No Briga. I can't say your username, bro, but he's a YouTuber who went ahead and let me know Control-Z actually suspends your process. It doesn't stop it. The more you know. So how do you end a Linux process? Well, that's pretty straightforward. We use the kill command, right? So if we were to do kill and then enter a process ID, we could kill a process. But first, let's list all the different signals we can send with kill. So as you can see, there's about 64 different signals you can send with kill. Thankfully, we generally only need to know 3. And again, those 3 are sigterm, sigkill, and sigup. Now let's practice killing a process. First, let's find one we can kill. Let's practice actually killing a process. So the very first thing we're going to want to do is open up HTOP, and we're going to want to find that process we want to kill. In my case, that process is 524384. So let's close HTOP, and then we can do kill 524384. And with that, when we open up HTOP again, you'll see the process is gone. And that's how you kill a process. By default, the kill command sends the sigterm signal. So it's basically politely asking that process to stop. What if we wanted to make that process stop, but not so politely? Well, we would do kill, and then we would set the signal, so reference that menu above, and then we would enter the process ID. Let's try that out. First, let's start that nice command again. So we could do nice-5dd if equals of equals. Cool. And from there, we can do htop to find that process ID. And as you can see, the process is now 565247. So now that we know the process ID, we can send the sigkill signal to that process. So to do that, we do kill -9, and the process was 565249. Helps if you get the process ID number right. This is Linux Lab 10-2, managing processes from the command line. The first thing you're going to want to do is go ahead and log in as root. I've already done that. Next, we're going to do dd if equals /dev0 of equals /dev0, and we're going to end it with an and sign to automatically send it to the background. And we're going to do that command 3 times. Then we're going to run a px aux grepdd, and you'll see we got a list of all the processes that start with dd. So we have a couple IP address processes right here, but what we're focused on is these 4 down here, or rather 5. After that, we're going to renice a process. So let's choose one of these right here. I'm going to go with the first one, that is 477721. So we'll do re-nice and 5 to raise its priority by 5. Then we do 477721. Now we run a PS fax, then we do grep-b5 dd. So now it's going to list us an output of all our processes with dd, right? But it's also going to list the last 5 lines too. So this is somewhat of a more readable form of dd. You see it shows the process ID, it shows the terminal it opened in, it shows the status, how long the process has been running, stuff like that. So we've got one right here, then we've got some underneath our bash session. These are the ones we just started. This seems like one I probably started a video or 2 ago. So now that we have a more readable output of DD, let's try to kill this DD process right there. So 477721 is the process we want to kill. So to kill it, we'll do kill -9 477721. Now when we run PS fax, that DD process is no longer there. It's gone. So we have our list of DD processes here. What if we wanted to kill all of them at the same time? Well, we could do kill all DD. Right, so we do kill all DD, and then when we run PS fax again, you can see all the processes that started with DD got closed. And that's that lab. Thank you for watching. There is actually another utility we can use to manage processes on Linux that's actually built into most Linux distros and all Red Hat based distros. That utility is Top. Let's dive deep into this utility. Top is a pretty useful utility. Let's start by seeing what features it has. So we use the H key to pull up its help menu, and let's read through some of these. I'm going to give you a couple seconds here. Go ahead and pause if you have to. So we can use the L key to actually do stuff like search for the process. So we hit L, and then we can do SSH, and you'll see it finds SSHD and it gives us some process information here. So let's highlight this field and let's break down what some of these settings mean right here. The first, of course, is the process ID right here. So that gives us the actual process that's running, and we can use that to stop the process. The second is the user, so it gives us who the process is running as. The fourth is the nice field, and this basically shows you how important a task is to the kernel. Most of these are set to default values of 0. After that, we have CPU percentage, memory percentage, time is how long the process has been running, and of course we have command for the command name. So you can see SSHD right there. So what if we want to kill a process using Top? We would hit the K key, and then we would enter the process ID for SSHD, so that is 364246, and it should kill SSHD. And there we go, it just killed that process. Otherwise, let's get started. Let's talk about TuneD and performance profiles. What are those? All right, I had to change the colors there. Everything was a little too red/pink for me. Now, let's talk about TuneD profiles. What are they and how do they work? Basically, when you set up a Red Hat Linux system, it applies what are called performance profiles. And there's a couple main ones you need to know about and a couple ones you don't. And you also need to know how to set performance profiles. So we'll see if we can condense all that down into a couple minutes or less. So what is TuneD exactly? TuneD is a daemon that lets us change different performance settings on a system automatically. TuneD is managed by TuneD admin. So first, let's see if we have this installed on the host. So TuneD admin, we do have TuneD admin installed. That's good. Then we can do systemctl status TuneD. So we can do systemctl status TuneD. So we can see that the TuneD daemon is running. After that, we're gonna go ahead and enable it. So we can do systemctl enable TuneD. Honestly, we didn't even need to have to run that command. Look up here, it's already enabled. So how do we view our current TuneD profile? Well, we do TuneD admin active. There we go. Added an extra character. So we have current active profile virtual guest. TuneD admin active gives us current active profile virtual guest, which makes sense because we currently have a virtual guest running, which is this server right here, right? So the performance profile makes sense that it is a virtual guest profile. if we were to do if we were to do tuned admin recommend, you would see the recommended profile for this is a virtual guest. So we do have the recommended profile applied. What if we want to change our tuned profile? Well, we can do that by using tuned admin. We can do tuned admin profile, and then we could set it to something like the through pro performance, right? And we might want to do that if we wanted this to be like a file server. So we want to give it more throughput, but we want to give it more I/O performance or network performance.